Well, now we want to look at how do we actually write these out or illustrate these aqueous reactions. Unlike previously where we just looked at it's this mass of this and this mass of this, well, there's nothing dealing with solutions, right? We don't have things broken up into ions, nothing like that. All we've looked at is saying we just have a reaction. Well, when we're dealing with aqueous reactions, the very special thing that happens there is that like something like this, barium chloride, actually doesn't exist in solution as barium chloride attached to itself. Okay, so we want to see, can we illustrate that in the way we write out our reactions? So we're going to write out our reaction in 3 different forms. We're going to write out our molecular reaction, which is like what we have here. Simply what compounds reacting with what compound to give us what other new compound, and then our final other compound that we have. Okay, so we would call this our molecular form of our reaction. What molecules or ionic compounds are present there for our reaction to happen. Now our next type of way that we can write out a reaction is actually illustrating what do those solutions actually look like. So we're going to write this in the form of our ionic equation. Okay, so think about our ionic equation as being what is actually present in our solution. Okay, remember we said barium chloride doesn't exist as barium attached to those 2 chloride ions. It's actually barium 2+, right? It's dissociated, so it's aqueous. And then we have those 2 chloride ions broken apart. Now if we have the subscript here, that means we actually have 2 of those chloride ions coming out of that one barium chloride unit. And then to that we have our other solution would encompass our sodium ions, so we'd have 2 sodium ions, which would be aqueous. And then we have our sulfate ions. Okay, so now we're saying this is in one solution, the barium and chloride ions. This is in our other solution, the sodium and sulfate ions. When we mix them together, we see we form barium sulfate. Well, now barium sulfate is not actually broken up into the 2 ions. It's a solid precipitate. So we see it just simply stays together. We have the barium attached to our sulfate solid. We see we have a solid there. It's not going to be broken up into the ions in solution. It's not dissolved. And then to that we have our 2 sodium ions, which are aqueous, and our 2 chloride ions, which are aqueous. Okay, and so we see, remember to keep through, following subscripts gives us the coefficients here, because we actually have 2 distinct sodium ions, and then if we have like 2 sodium chlorides, that would mean 2 sodium ions, 2 chloride ions, because we got to keep it balanced. So when you see with our ionic equation, it basically says what ions are present, what's actually present in our solution. So that's useful because it tells us if we have everything that's the same on both sides, no reaction's happening. Our ions just stay the same. We're just, in theory, switching ion partners. Well, we aren't, in theory, switching ion partners because we actually are forming that barium sulfate. Now we have the ability to see what's actually there. Maybe we want to hone into, well, what's important? That would be our net ionic equation. Okay, our net ionic equation illustrates simply what is reacting. So which ions are actually reacting? Which ions are not reacting? When are they there just to keep the charge of our solutions neutral? Okay, well, how would we identify this? What we would do is we would go through and we'd see, are there specific ions that stay in the same form and the same amount as reactants and products? So we go and we see, well, something like we have these 2 chloride ions. Well, now we have these 2 chloride ions there. They haven't changed form. They haven't changed amount. We still have 2 of them. We also have the same thing true for our sodium ions. We have 2 sodium ions here, and we have 2 sodium ions there. Okay, these that stay the same in amount and type, right, charge, everything, those are what we call spectator ions. Okay, our spectator ions are there along for the ride, just like if you're watching a soccer game or a football game. You're a spectator, you're just watching what's happening, but you're not doing anything. That's what these ions are doing. They're just watching what's happening. They're along for the ride. Well, they aren't reacting, right? They haven't changed form. So when we go from our ionic to our net ionic equation, we get rid of those spectator ions. So we see what we would get rid of, so we could go ahead and say, well, we don't have chloride anymore when we go to our net ionic, and we don't have sodium ions anymore when we go to our net ionic. So we could go ahead and write our net ionic equation as being what's left over. the barium ions reacting with our sulfate ions, and that's going to form our solid precipitate here, which is our driving force for this reaction to happen. So we see our net ionic equation simply says what's reacting with what? What two ions are combining in this case to give us our barium sulfate? Now if we do this and we get to everything as a spectator ion, well, we classify that as no reaction. Nothing's happening. There's no change from reactants to products. Well, that wasn't the case here because we had the driving force in this case of the formation of our precipitate.